In this video, I'm going to go over an example SAT math problem that deals with zeros and multiplicity. Now if we look at this function, if I wanted to find zeros of this function, I would set each parenthesis equal to 0 and solve for x. So minus 1, so x equals negative 1, add 1 here, x equals 1. So I would have zeros at x equals negative 1 and positive 1. Now if we look at the graph, we get x equals negative 1 and positive 1. And we see at each of these intercepts, the line goes right through there. Now if I look at this function, again I can do x plus 1 equals 0, and x minus 1 equals 0, so we get x equals 1 here, and x equals negative 1. But here we have 2, so I have another x minus 1 equals 0, and x equals 1. So I have 2 at x equals 1. If we look at the graph, so this graph looks different than the first one. Here at negative 1 it goes right through it. At positive 1 it goes towards it, hits it, and comes back. So this is what happens when you have 2 at that intercept. So this is the first one and second one. Okay, so if you have 2 at the same location, it's going to hit that intercept and then bounce back. You see the first one had a multiplicity of 1, so it went right through it. So the one had a multiplicity of 2, hit the intercept, and bounced off of it. Look at this one. We have a multiplicity of 1 here and 3 for that one. So let's check out the graph of this one. So multiplicity of 1, we go right through it. When we have 3, we can see that it hits the intercept, kind of goes flat, and then goes back up. So this is when you have a multiplicity of 3. So the rules are, if you have a multiplicity of 1, it just goes right through it. When you have an even number, so 2, 4, 6, 8, it doesn't matter. If it's, as long as it's even, it's going to hit the intercept and bounce right off of it. If it's an odd number, like 3, 5, 7, it's going to go towards it, kind of flatten out, and then go back up. So it's going to go through the intercept. We're going to see it flatten out as it approaches it. So this SAT problem says, the graph of the function f is shown in the xy plane above, where y equals f of x. Which of the following could define f? Okay, so first we need to find out where the intercepts are. We got one here at negative 2, one here at negative 1, another one here at 3. So the one at negative 2 is going to be x plus 2. We got to change the sign. One at negative 1 is going to be x plus 1. And the one at 3 is going to be x minus 3. Alright, now we need to check out the multiplicity. You see at negative 2, it just goes right through it. So that's just going to be 1. At negative 1, it hits it and bounces back. So we said that was 2. So that's going to be squared here. And at x equals 3, again, it hits it and bounces back. So it's going to be multiplicity of 2. So that's going to give us answer C. Alright, so this problem dealt with zeros of a graph and multiplicity. I want to thank you for watching this video, and hopefully you learned something. You can help support this channel by liking this video and subscribing. That would be greatly appreciated. And don't forget to check out our other videos involving SAT math. Thanks.